Hey there, class. I'm going to take a video here to make sure you're prepared for the test on Thursday. These questions are based off your test questions, so if you can handle these questions, you can definitely handle your test. All right, our first question here is a left, right, and middle rectangular sum or a Riemann sum. So I'll do it with right rectangle, left rectangle, and then middle rectangle. Now, in this situation, I have some sort of, I could tell from a parabola. So I need values, oh, I didn't say, from n of 4. So there's 4 equal pieces here. So in this situation, I want 4 rectangles for this function from 0 to 8. So if I want 4 pieces, that means I'm going to need it to be 2 wide, and I know it's going to be 2 wide because 8 minus 0 is 8, 8 divided by 4 is 2. So from 0 to 2, 2 to 4, 4 to 6, 6 to 8. That will make 4 rectangles, okay? Then I'm going to need the values, the height values of each section. So at 0, it's 0. At 2, it's negative 4. At 4, it's 8. At 8, or at 6, it is 36. And at 8, it is at 80. And I get these values by taking these numbers here and just plugging it into my function, okay? I have them done on the calculator already to save some time. But yeah, you just plug those into the equation. All right, so if I'm looking for a right RAM or a right rectangle approximation method, what I'm going to do is take my 4 right values. So it's going to be these here. So I use the same formula for all of these, where it's going to be base times the various heights, to height n, whatever it might be. So in this case, for this one, the base is the distance between the two parts, which is 2. And the height here is going to be all my values I have here. So negative 4 plus 8 plus 36 plus 80. Remember, a negative area just means that it's underneath the y-axis. So this is a rectangle that's 2 wide that is 4 units below the y-axis. So when you see a negative value, that's totally okay for area. So in this case, you're going to add these numbers up. Negative 4 plus 8 is 4. 4 plus 36 is 40. 40 plus 80 is 120. 120 times 2. Your approximation for this one is 240. For a left rectangular approximation form, I'm going to use the 4 left values. And within the name, it's pretty obvious which ones I do. So in this case, my base is still 2 because the boxes are still 2 wide. In this case, I'm taking the 2 values, the 4 values from the left. A little bit easier. Negative 4 plus 8 is still 4. 4 plus 36 is still 40. So 2 times 40 equals 80. So when we take the middle sum, though, this is a little different. I need to take the values at the middle. That means at 0, 2, I need the value at 1. I need the value at 3. I need a value at 5. And I need the value at 7. Which means I'm going to take this 1 and plug it into here. 3, plug it in here. 5, plug it in here. 7, plug it in here. You could have pre-made your tables like 0, 1, 2, 3, 4, 5, 6, 7, 8 in preparation for that. That's totally fine. So I need 1, 3, 5, and 7. I need those numbers, which are going to be 1 is negative 4, 3 is 0, 5 is 20, and 7 is 56. And you can plug those into your calculator if you don't trust me. But either way, the middle RAM takes the values of the middle points. So we got to make sure we get those. But then afterwards, it's just the same thing. We're just using these 4 numbers. Negative 4 plus 0 plus 20 plus, this is 56. So 16 plus 56 is 72. 72 times 2 is 144. All right. So next thing we're going to do is our geometric version. So the geometric version is when we just kind of draw out the shape and see how it looks like, and we could use simple geometric areas. So for example, our rectangle is f of x equals 4 from -2 to 3. So from -2 to 3, we have a line, a horizontal line at 4. Oh, I missed. In this case, you should see that it forms a rectangle that is from 3 to -2, 5 wide, and that is 4 high. So the area of this is 20. So the area of this one is 20, and it's clearly shown because it's a rectangle. In this one, 3x as from 0 to 4. This one, you need to know how to graph y equals mx plus b. Okay. Knowing how to graph y equals mx plus b is very important. In this case, this is 3, m is 3, and it's 0. B is 0. So we're going to have an intersection at 0. I'll use a different color. We're going to be at 0. And then that's 3 up, 1 right. 3 up, 1 right. 3 up, 1 right. 3 up, 1 right. 1, 2, 3. 3 up, 1 right. We're only going to 4, so we'll stop right there. And hopefully you can see that that forms a right triangle where it's 12 high and 4 wide. The formula for a triangle is base times height. So base times height divided by 2. 12 times 4 divided by 2. That ends up being 28. Next one is going to be square root x squared minus 6 from -4 to 0. Now this one you might not recognize right away, but you would kind of recognize it, and I know because we did it in class, if it looked like this. In this situation, it should be obvious this, if converted to here, is a circle. This is a circle. Because you would subtract x squared both sides, square root both sides. You could take out a -1 first if you want. But this should be a circle of some sort, okay? So in this case, if it's a semicircle, you could tell that this number right here is going to be your radius, okay? Which means it's a semicircle from here, from -4 to 0. If it was -4 to 4, it would be the whole way through. Like it would be the whole way through. But in this case, it's just this part. So in this situation, it's this area right here. Since I have a quarter of a circle, if I have a quarter of a circle, it's going to be the circle formula, which is pi r squared, and a quarter of it, so divided by 4. If it was half of it, divided by 2. If it was a whole thing, you want to divide anything. So pi times 4 squared divided by 4. It turns out that simplifies to 4 pi. You don't actually have to type in 4 pi in the calculator. You could leave it in terms of pi. But the area in this case is 4 pi. I will give you grids to graph your thing if you need it. Actually, you do need to graph it because you're showing me which geometric symbol you're using. But I'm going to have 2 questions. It's going to be one of these, 2 out of 3 of these, okay? All right, using antiderivatives. So this is the main chunk of integrals, and this is going to be useful for the next chapter too. So we use antiderivatives to describe this part right here. So in order to do that, there's a general rule that says the f of x of an integral, dx, is equal, let's say from b to a, is equal to the antiderivative, so capital F of x, from b to a, okay? So in this case, we have f of x dx is become the antiderivative, so I want the antiderivative of this. As a reminder, to get the antiderivative, you're going to add 1 to the power and divide it by that new result, which happens to be 2 plus 1, 3. Over here, you're going to add 1 to the power and divide it by that result, which in this case is 2. So our antiderivative is 3 divided by 3 cancels out. So x to the third minus x squared over 2. So minus x squared over 2 from 2 to 4. And you get those values from here, 2 to 4. Then that means I'm going to plug in 4, I'm going to plug in 2, and subtract the difference. So 4 to the third power minus 4 to the second power divided by 2 minus 2 to the third power minus 2 to the second power over 2. So this is 4, 16, 64. 16 divided by 2 minus 8 minus 8 minus 2 squared divided by 2 is just 2, so 2. So 56 minus 6, 50 would be my answer here. So you want to use antiderivatives to figure it out, and that's how you do it. If you have something like this, notice in this situation, it's unbounded. There's nothing here and here. Because there's nothing in here, we're just going to do the antiderivative. So we do the antiderivative, which means I'm going to have to convert this to x to the 1/3 power. Then I'm going to have to plus 1, then divided by the new sum. 1, which is 3 over 3, plus 1/3 is 4 over thirds. Remember, 4 over thirds gets rewritten when you divide it as 3 over 4. Okay. So I'm going to rewrite this as 3, to make it more clean, the cube root of x to the 4th power over 4. When you have an unbounded integral, though, what's really important is that when you have an unbounded integral, you're going to have to do plus c. The reason you do plus c is because since we're in unbounded, I have no clue if my area is like, let's say, over here or over here. So I had to put that plus c because when you do an antiderivative, I don't know how much I have left over. Because anytime you derive something, like let's say you derive x squared plus 6, you would get 2x. While here, if you derived x squared plus 10, you also get 2x. So when I do an antiderivative without a bound, I need to put the plus c because it represents this mysterious c that used to be here. That mysterious c that used to be here. I don't need to do that when I have particular values because when I subtract the two areas, it doesn't matter because even if it was raised up, the difference of the areas will still be the same. While over here, this will be different. So that's why you need a plus c for unbounded, while you don't need a plus c for this. This is, yeah. All right, some antiderivatives are not typical to like just the power rule. If you get 1 over x squared, you would rewrite that as x to the negative 2 power. Then you would do the plus 1 divided by the new number, which is negative 1, which you would rewrite as negative 1 over x. Because it'll be x to the negative 1, and I would bring it down. But if you had 1 over x, you'll realize something's weird because it'll be x to the negative 1. Plus 1 causes 0, which you divide by 0. That's impossible. But then you have to ask yourself, what derives gives you 1 over x? And that answer is actually ln x. So if you see 1 over x, you would get ln x. Also remember the trig rules, and I'm just going to keep it a sine and cosine. Sine becomes cosine, which becomes negative sine, which becomes negative cosine, which negative cosine comes back again to sine. Remember, this is the derivatives. what I just did was the derivatives. Okay? So going upwards will give you the antiderivative, okay? So going down will give you the derivatives. Going up will give you the antiderivatives, okay? So always make sure you do it correctly. Pretty much it's like, is it negative or positive is the question you're going to have to ask yourself. Okay? There's no other weird antiderivatives. After the test, we'll learn harder antiderivatives later. Okay, with that in mind, that's what is for the test. Good luck and have a wonderful rest of your day.